Hello Antioch Bears, Mr. Crawford here, going over Integrated Math 2, Practice 2, Linear Nonlinear Functions, where we work on the tables and the graphs. The directions for the classwork say a table of values allows you to plug in any number for the independent variable x and produce ordered pairs that can be graphed on the coordinate plane. That's what we want to do with each one of these four functions here. Linear function, quadratic, polynomial or cubic, and exponential. I'm going to choose the exact same values for x and y over and over again. I'm going to use -2, -1, 0, 1, and 2. What I want to do is take each one of these numbers, plug them into the function, do the math that is involved in the function over here on the right, and produce myself a corresponding y value that will then go down here to the little graph and plot. So first up, if I take -2 and plug it in for x in the linear function, 2 times -2 would be -4 plus 3 would be -1. If I plug in -1 for x, 2 times -1 is -2 plus 3 is a +1. If I plug in 0, 2 times 0 is 0, 0 plus 3 is 3. Plug in 1, 2 times 1 is 2, plus 3 is 5. Plug in 2, 2 times 2 is 4, plus 3 makes 7. I then want to go to the coordinate plane, plot the points. -2, -1 would be left 2, down 1. -1, +1 would be left 1, up 1. 0, 3 would be up 3. 1, 5 would be right 1, up 5. And 2, 7 would be right 2 and up 7. You may notice that this little graph only goes up to 6. That's fine. Just estimate as best you can. And you will see this indeed makes a straight line. That is why it's called a linear function. The quadratic function, same numbers. If I were to plug in -2 for this function, -2 squared is a 4. -3 times -2 is a +6. So 4 plus 6 is 10, minus 4 would make 6. If I plug in -1, -1 squared is 1. -3 times -1 is +3, still minus 4. 1 plus 3 is 4, and 4 minus 4 makes 0. If I plug in 0, that makes it easy because these first two are just going to cancel. 0 squared and -3 times 0, all that makes 0. So I end up with just -4. When I plug in +1, 1 squared is 1, -3 times 1 is -3, minus 4. 1 minus 3 is -2, -2 minus 4 is -6. If I plug in the last number 2, 2 squared is 4, -3 times 2 is -6, minus 4. 4 minus 6 is -2, minus 4, I end up with -6. Plot these points. -2, 6 is left 2, up 6. -1, 0 is left 1, stay there. 0, -4 is down 4. 1, -6 is right 1, down 6. 2, -6 is right 2, down 6. I know that this makes the shape of a parabola. I think it's going to turn around right there and come back up. Something like that. The cubic function, same numbers, -2, -1, 0, 1, 2. If I plug in -2, -2 to the third power is -8, and -8 plus 1 would be -7. If I plug in -1, -1 to the third power is -1, then plus 1 is 0. If I plug in 0, 0 cubed is 0, 0 plus 1 makes 1. If I plug in 1, 1 to the third power is 1, plus 1 would be 2. If I plug in 2, 2 to the third power is 8, plus 1 makes 9. Now I have ordered pairs, -2, -7, left 2, down 7. -1, 0, left 1, and stay there. 0, 1, go up 1. 1, 2, you go to the right 1 and up 2. And 2, 9, you'd go to the right 2 and up 9, way up here. So you can see the snake shape that this cubic function makes. Okay? -2, -1, 0, 1, and 2 in the exponential function. This one's kind of tricky because a lot of students don't know the laws of exponents well enough to know what happens here. But if you were to take 2 and then plug in -2 where the x is, which is a power, it would be 2 to the -2 power. That actually makes the number 1/4. Because negative exponents move to the bottom of a fraction and become positive, and then you stick a 1 at the top. Well, 2 squared is 4, so it ends up being just 1/4 or 1/4. Same thing is true with -1. If you plug it in, you end up with the number 1/2. Plugging in 0, anything to the power of 0 is just the number 1. If I plug in 1, 2 to the first power is 2. And if I plug in 2, 2 to the second power makes 4. Plot these points. -2 and 1/4 would be left 2 and up 1/4. Not quite all the way up to 1, just a little ways off that line. -1 and 1/2 would be left 1 and up a little bit, not much. 0, 1 would be up 1. +1, 2 would be right 1, up 2. And 2, 4 would be right 2 and up 4. And you can see the shape this exponential graph makes. It's kind of flat on that left-hand side and then starts shooting up, like so. Down here, I'm not going to write anything. This is basically up to you guys. I want to see your writing. Describe how to tell if a function is linear, quadratic, polynomial, or exponential from its graph, equation, or table. I mainly want you to focus on graph and equation. We'll talk about table in just a second. Its graph, I want you to be able to describe the shape. A linear function makes a straight line. A quadratic function makes the U shape that we call a parabola. Right? Parabola. Cubic function makes that little snake shape, and exponential functions make this rising shape here. So any way you can describe that in words is what I'm looking for. I also want to know how you can tell from the equation. How do you know if it's a linear function when you're looking at the equation? The x you see will only be to the power of 1. If you don't see an exponent here, it's understood to be 1. A quadratic equation will have x to the power of 2. A polynomial cubic function will have x to the power of 3. And an exponential function, x will be the exponent itself. So however you think to write that in words, as concise as you can, but explain all that to me, the more credit you'll get for that question. Okay, flipping it to the back. I want you to identify each one of these 9 as a linear function, quadratic function, polynomial function, which could also be cubic. If you wrote the word cubic, that's fine, or exponential. So what's this one? Well, the shape of it indicates that this is an exponential graph. Exponentials start off kind of flat and then can go up very quickly like so. So this one's exponential. Number 2 is an actual equation. This equation would have to be quadratic. Quadratic. Why? Because I see x to the second power. That makes this a quadratic equation. Now let's talk about the tables for a bit. If you notice that on the right-hand side where the y or the f of x is, if you notice a pattern where something is multiplying every time, like I see here, that means this is an exponential function. I notice that the f of x's keep going up by a factor of times 3. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. So every single time, that number is multiplying 3 to go up to the next one. Anytime you see something multiplying like that, same thing every time, you know you're dealing with an exponential graph. If we tried to graph it, it would look something like this. Okay? Here's another table, number 4. This one, that's not happening, the same thing that was going on in number 3. There's something else happening here. What I want to calculate is something called the first differences. I want to notice what the change of y is, either by adding or subtracting. When 6 goes to 9, you could get there by adding 3. 6 plus 3 would make 9. Then if I wanted to go from 9 to 12, I could also get there by doing the same thing, adding 3. If I want to go from 12 to 15, again, plus 3. If you ever notice that the first differences are the same thing, something's adding or subtracting every time, same number, this is a linear function. If we graphed that, it would make us a straight line. Number 5, you can see the shape of the parabola. It's upside down, but that's all good. That still tells me that that's a quadratic equation. Number 6, I notice that the highest power is right behind this 4. That's an x to the power of 3, which makes this a cubic function, otherwise known as a polynomial. But polynomials can have more than just the third power. It could be the 4th, 5th, 6th, so forth. Down here in number 7, I see a big 3, and then the exponent is x minus 2. Anytime your x, your variable, is part of the exponent, that's an exponential function. Number 8, I don't see anything multiplying, so it's not exponential. I'm going to calculate the first differences. To go from 10 to 11, that's a plus 1. From 11 to 14, that's a plus 3. From 14 to 19 is a plus 5. Well, the first differences are not the same like they were over here. So I also know it's not linear, or it would be the same number happening every time. So now I'm going to calculate the second differences. I'm going to do that exact same process, just with the numbers that I have on the outside. To go from 1 to 3, that's a plus 2. To go from 2 to 5, that's also a plus 2. So the second differences turn out to be the same. If the second differences are the same, this guy is quadratic. It would be making a parabola when we graphed it. Finally, see the graph of that famous snake shape, right? I'll know that to be a cubic function. All right. Hope this helps. I'll see you guys next class.